So today I'm going to talk about how you can improve the web platform. So first, let's discuss why you would want to do that. And my focus here is interoperability. And I define that as browsers doing the same thing for the same piece of code. I hope that's clear enough. But for example, if you have a list element in HTML, then it should render the same in Firefox as it does in Safari or Chrome. Last year, there was a survey from MDN called Developer Needs Assessment. And one of the things that was identified as a top pain point for web developers was interoperability. So what you'll learn from this talk, I will discuss how to practically investigate a browser bug, how to use HTTP archive for web compatibility research, how to find the right people in browser engine projects, how to write a web platform test, and briefly how to go about changing a spec at the W3C or the WPTF. So who am I? I started contributing to the WPTF in 2005. One of my first proposals was the short doc type that everyone is using today. I worked at Opera Software on quality assurance and web standards between 2007 and 2017. Some of the features that I worked on was the video element, web workers, WebSocket, and more recently the picture element. I am one of the editors of the WPTF HTML standard. Currently, I work at BigQuery, which is a web consultancy firm. We're currently focusing on accessibility and InfoSec standards and rendering interoperability, at least the stuff that I'm working on. I'm also working on a book called Idiosyncrasies of the HTML Parser. This is currently a work in progress, but it's free to read if you like. You can check my Twitter if you want to find a link to this book. Okay, so how do you investigate a bug? Let's say that you have a web page that you are working on or that you just using, and you find that it renders differently in two different browsers. One obvious approach is to use DevTools or whatever you usually use to debug a problem to find the thing that is being different between browsers. Another way that is kind of the traditional way that doesn't always work, but sometimes it does, is to just remove code until the bug doesn't reproduce anymore, and then take a step back and remove a little bit less. The end goal is to end up with a minimized demo. So a demo here is like a test case, but it doesn't necessarily have a pass condition. So it doesn't say which behavior is the right one, but it still reproduces the bug that you're interested in. There's a page on MDN that goes through how to reduce test cases. So here's an example of a demo. I have 4 select elements and apply some different styles to them. The first one is without any styles at all. And then you have 1 pixel solid border and 2 pixel solid border, and then -WebKit -appearance none. And the link at the top loads this demo in a tool called Live DOM Viewer, which is a tool that Ian Hickson developed while he was specifying the HTML parser in the HTML standard. So what's the result of loading this page in different browsers? Here are some screenshots that I took in Safari. You have the native select style for the first two cases, and then a different style for the 2-pixel solid border, and then a third style again with WebKit appearance none. And as you can see, all of these 4 cases in Safari have rounded borders. In Firefox, the result is different. The second case no longer has the native style, but instead has a Windows 95 style drop-down button. And the WebKit appearance none case doesn't have rounded borders. And then in Chrome and Edge, we see a few different results depending on the version. So they recently made a change to how form controls look to be more modern and more stylable. And this changed the default styles as well. You can see that in Chrome 83 and 85, the WebKit appearance none case doesn't have rounded borders. But in Chrome 81, it did have rounded borders, and the background color is different as well. One minor difference in Edge compared to recent Chrome is that Edge maintains a slight border radius in all cases, whereas in recent Chrome, only the first unstyled case has a border radius. So this is an example of lacking interoperability between browsers. So let's talk about a principle that browser engines and standards projects have when making changes to the web or the web platform, and that is essentially don't break the web. There's a document called HTML Design Principles from the W3C, and one of the principles is support existing content. And from the Blink project, they have a document called Blink Principles of Web Compatibility. And I'd like to read this quote because I think it kind of drives the point home a bit. There are around 771 billion web pages viewed in Chrome every month, not counting other Chromium-based browsers. So seriously breaking even 0.0001% still results in someone being frustrated every 3 seconds, and so not to be taken lightly. So the reason browsers don't want to break the web, essentially, is that not only that their users will be annoyed, but also if a page works in one browser and not in the other browser, that gives users an incentive to switch to the other browser that works. And that's why browsers normally don't want to break things that work. So how do you find out if something would break? There's a project called HTTP Archive that I have used quite a lot. This project tracks how the web is built. Twice a month, it crawls 5 million web pages and includes the full response bodies of the HTML and the CSS and the JavaScript, and also other data about these web pages. And then there's a tutorial for how to get started with HTTP Archive using the BigQuery tool. This should be accessible from httparchive.org. So here's an example of something that HTTP Archive collects: the total web page size of the median web page. So as you can see, it's been increasing over time. And on desktop, the median web page weighs about 2 megabytes. And on mobile, it's 1.8 megabytes. So that's kind of depressing and also impressive, depending on how you see it. But usually I'm more interested in diving deep into the response bodies because I'm looking for something very specific. So for example, when I worked on the WebKit appearance CSS property, I want to know which values web pages use. So you can use BigQuery and write an SQL query and extract with a regexp the values for WebKit appearance, and then group them together and count how many pages match. So what is the result of this query? This is a fraction of the full table, but the most common value is the none value, so WebKit-appearance:none. And then the second most value is the button value, which is used roughly the same amount as none. And then it goes down from there. But for example, a browser would need to support the checkbox value, because if it doesn't support that value, it will probably break web pages that expects that value to work. So in the CSS appearance spec, it tries to simplify how the appearance property works, but it has a list of compat values that map to the auto keyword, so it has the same behavior. And checkbox is one of those compat values. So the idea is web pages that use WebKit appearance checkbox would act as if they actually used appearance:auto. Okay, so let's say you want to make a change in browsers. How would you find the right people for the different browsers? First, you need to realize that the different browsers have an underlying rendering engine, and those are open source projects, at least for those that are being actively maintained today. Those are Gecko, WebKit, and Chromium. One approach to finding a person behind the code is to get the code and then find the implementation of the feature that you're interested in. And depending on if the project uses Git, or I think Gecko uses HG, but the principle is the same. You look at the version history to see who has touched the implementation. There's a problem with this though, because there are often changes that are unrelated to the code at hand, because maybe there's a reformatting change or something. So you need to look at the commit and maybe go further back in history to see who actually implemented the change. Another approach is to look at the public bug trackers for these projects and search for bugs that have been fixed for the feature, and who was the assignee and who was the reviewer. Those are probably people who know about the feature. And then these projects typically also have API owners, or WebKit has reviewers. For Mozilla, there's a wiki page that lists the various people for different modules. And for Chromium, in the source code, there are owners files. with people responsible for that piece of or that API. So it's easy to get a long list of people that you could email, but keep in mind that they don't have any obligation to respond to anyone in particular that asks things of them. So I was advised to keep your message short, and if there's a public issue, link to it with more information. And also say why you're contacting them in particular. For example, if they fixed a bug, you can link to that bug. And also, I think it's nice to limit yourself to one person from each project and say, if you're not the right person, please forward to someone who is. And again, you might not get any response, but allow 1 week to pass and see if they respond. Another approach is to reach for a wider audience within these projects. There are different ways to do this. One way is to file a new issue. These projects also have discussion groups or mailing lists and have like a catch-all entry points usually. And they also have Slack or IRC where you can ask questions. Okay, so let's switch to web platform tests. This is a shared test suite, primarily for browser engines, but also for other projects that implement the web platform, such as JS-DOM, Node.js, and recent Deno. I think I'll use web platform tests for some of their APIs. There's a documentation site for how to use web platform tests with all of its how to write a test essentially and how it's structured. So most of these tests are automated and there are different kinds of tests, but here I'm only going to talk about the JavaScript kind. So there's a harness called test-harness.js in web platform tests. And this is an example test testing the appearance property using test-harness.js. So this harness provides the test function and also the assert equals function, and also has support for asynchronous tests or promise tests, and has lots of other assertion functions and such. But in this case, the test creates a normal input element and sets the style attributes to appearance : none. Note that it's not using the WebKit prefix in this test. And then it asserts that get property value for appearance is the string none. And if it is, it will pass the test. Otherwise, it will throw an exception at this point and fail the test. WPT.FYI is a website that shows test results for every automated test in web platform tests in different browsers. So here we see the test results for this test in Chrome Dev 84, Edge Dev 84, Firefox Nightly 78, and Safari Tech Preview 106. And since the test wasn't using the WebKit prefix, it only passes in Chrome and Edge, where this change was just landed in for M84, so version 84. Hopefully it will start to pass in Firefox and Safari as well, but we can use this this page on wpt.fyi to track progress. So let's say that you have a feature that you want to test. It's often not enough to just write a single test. You need to have reasonable test coverage. So one way to do that is to start out with a testing plan. And in the WPT docs, there's a page called Making a Testing Plan that explains how to do this well. Essentially, you start out by reading the spec and try to enumerate all possible things to test. However, all cases that are possible to test often is an infinitely long list. So you need to constrain yourself and exclude things that are not interesting to test. This page also explains how to approach finding existing tests, which can be a bit difficult because the web platform is large. Okay, so let's say that you have investigated a bug, you have written a test, now you want to change the spec. First things first, you need to make sure that you have the intellectual property rights cleared. And this is because the web platform should be royalty free. So anyone suggesting changes needs to sign a CLA or join a working group, depending on if it's W3C or the WPTF. It either needs to be you personally or your employer. Assuming that's out of the way, the first step I would recommend is try to build the spec locally. Different specs have different tools to generate the actual spec. Most CSS specs and WPTF specs use a tool called BikeShed. Some other W3C specs use a tool called respec, which is running in the browser as JavaScript, so you don't need to install anything to use that. For the WPTF HTML standard, it has a custom build step, and this is in a repository called HTML-build. Then you would want to try to follow the specs formatting conventions, and this is usually documented in the repo in a contributing file or README or so. Otherwise, you can try to look at the surrounding markup and use the same convention. And then you make your change and submit a pull request like any other open source project. In your PR, you should link to the tests, if there are tests. And then you can ask implementers and spec editors to review your change and follow up to address review comments. And hopefully you can land your change. There's more to it than this, but this is technically what you need to do. There are things to keep in mind about how to read a spec and how to write a spec. So if you want to learn more about how to read a spec and how to write a spec, and essentially everything that I've talked about in this talk is covered in an online book that BigQuery is announcing today. It's at wpc.guide. So you can be the first to read it if you are interested in this. And that's it. You can follow me on Twitter if you like. We can go to Q&A.
Yeah, thanks so much, Simon, for the talk.
Thank you.
So we now have the Q&A open on Zoom. So if anyone would like to ask a question, we have a couple already. Yeah, just type it in. I think there was one quite a while ago from Igor. He asks, they ask, why would I want to create web platform tests? What's in it for me as a developer? What can a developer gain by using one of these test suites?
That's a very good question. So I think the answer is that it's more likely that the bug will be fixed if it has a good test. And also for spec changes, if you want to get a spec change landed, at least in the WebWig, but also in many working groups at the W3C, they have a policy that requires tests to land a spec change. But the reason for that policy is exactly that it's more likely that browsers will notice that something changed because now they see that they have a new failing test essentially, and that's part of their CI system. When a spec changes, they might not notice for maybe a few years or 10 years. If you write a test, they might notice within weeks and hopefully fix the bug. So I think that's the selling point for writing tests. It shortens the time to get things fixed and reach interoperability in browsers.
Great. So it's a way to, tests are kind of a means to an end for changing the web platform in a way that we can more
much like
precisely
the specification itself is also a means to an end. The goal shouldn't be to have a specification. The goal should be to have something usable in web browsers, and how to reach there is through standards and tests, at least if you want interoperability.
Like a good open web platform.
Yeah.
Let's see. So we have another question from an anonymous asker, somewhat shy, I suppose. How long does it take for a fix for a specification to land in an actual browser?
It depends is the short answer. The longer answer is I've seen trivial changes go from specification issue to the spec being fixed, there being a test, and browsers being interoperable, at least for the nightly versions, in less than a month. I shared this on Twitter the other day. Let's see if I can find this. Yeah, it was the case sensitivity of the target attribute, or the equivalent feature for window.open. So this was filed as a spec issue in March 2017. And then we researched HTTP archive, and Chris Dumas is a WebKit implementer. T-Kent is a Google implementer. They agreed with the change, and I filed bugs, and they were fixed in less than a month. So this is a fast case. It's more common that it takes around a year, but it can also take like 10 years. It depends a lot on what the change is. But if someone does the heavy lifting by following the process that I outlined in this talk, that should quicken up or lower the barrier for browsers to go ahead and fix the issue.
So I'm actually interested. I have my own quick question here. You mentioned that there are these different implementers for these different browser engines.
Yeah.
How often does it come up that they actually don't agree on either a particular implementation or a particular spec fix? So if someone points out, hey, this is an issue, what if, I don't know, a Chromium dev says works as intended, and the Firefox, the Gecko people and the Edge people are unhappy with that? Is there some sort of way to resolve that, or does it happen ever?
It does happen. It happens pretty often, actually, that they disagree. And usually it's the spec editor's job to try to resolve that issue. But if there's a person driving a change, they can also try themselves to resolve issues like this. But I would say that it's the spec editor's job first to resolve such issues. One example where that has happened is with the Shadow DOM, I think, has various disagreements between different browser projects on how the feature should work. Yeah, I don't have enough inside knowledge of Shadow DOM, and I wouldn't be able to explain it in a short amount of time either. But it's one example where browser projects disagree on how something should work.
Excellent. I think that's probably it for the Q&A of this talk. So I'd like to thank Simon again for joining us. And,
Thank you.